SSL Forward Proxy is one of those features that if you don't understand the fundamentals, it's going to be very hard for you to pass on the PCNSE exam, or in case you plan to deploy this feature in a production environment using the Palo Alto Firewalls. So in this video, I'm going to show you not only how to deploy this feature, but understanding the reason behind we need this feature in first place. Now, to help me explain how this concept works, I'm going to use this document from Palo Alto. And you can see we have a client here, we have a firewall, and we have a server. Now, let's suppose that this server is your bank's web server. So let's call this www.bank.com. And this server is being served on the port 80. Okay, that essentially means this is using HTTP. Now, something that we already know is that services that are running on HTTP or port 80 means that they're being sent in clear text. This means that when you as the client or the client log into the web server or the bank website, is going to provide the username and password. All of these will be in clear text. Although the firewall is inspecting, it means that if we have someone in the middle, like an attacker, if he's sniffing the traffic, probably here or here, he should be able to capture those credentials, the username and the password, and then he could use those credentials by himself. So to prevent that from happening, the servers have to make those services available, but in a secure way. And to do that, we now use 443 by default, but essentially we are using HTTPS. Okay, with HTTPS, the traffic that flows from the client to the server is being encrypted. So which means that an attacker that tries to capture that traffic in the middle, it won't be able to read it because the traffic is going to be encrypted in transit. Now, this is great because the attackers won't be able to read the traffic because it's being encrypted from the client to the server. But this also means that the firewall won't be able to see what type of traffic is being sent because now it's being encrypted as well. So to solve this problem, we have to allow the firewall to decrypt the traffic, and that's where SSL Forward Proxy comes into play. With this feature, the firewall is going to, let me delete this, so it's going to intercept the requests coming from the client to the server, which means that the client is going to establish this tunnel with the firewall, and the firewall is going to establish another tunnel with the server. This way, the firewall will be able to inspect the type of traffic and apply whatever policy we might have defined on our firewall. Okay, this is the topology that I'll be using. I'm going to focus on this device. So we have the Linux 5, this is going to act as the client PC. We have the firewall with two zones. So on this direction, we have the inside zone, and on this one, we have the outside zone that connects to the switch, this router SP acting as the gateway. And this router is connected to this switch where I have the network 1168. So let me delete that. 1168.40/24. And I have these two servers, Linux 14 and Linux 6. They're going to act as web servers, and we're going to enable HTTP and HTTPS on these two servers. Now, I have configured already on Linux 14. I'm just going to show you how to enable this on Linux 6, just for the sake of time. Okay, before making any changes, let me just show you what I have configured so far. So this is the basic deployment with the interface, default route configure, and a policy just allowing HTTP and HTTPS traffic to any destination. So if we go to Linux 5, that's the client PC, and let's go to one of the web servers. So at this time, only the Linux 14 is configured. So if we go to 1.168.4.14, so we should be able to see the web server running on port 80. So we can go also to HTTPS. Okay, so the firewall is just allowing this traffic, is not looking at certificate or anything related. So we can see this is We have a warning there, connection is not secure. So let's expand this, more information. Now let's take a look at view certificate. So this is the self-signed certificate that I generated on the server. So it's basic information about the certificate on the server: Linux 14, binary avenue, IT, Linux 14, organization. So this is everything that exists on the certificate on the server. Okay. So right now, if we try to go to 1.16846, it's not running because I haven't enabled this service yet. Okay, so the first thing we have to do on the firewall is to create a couple of certificates. So to do that, let's go to device, and then we go to certificate management, certificates, and here we're going to generate 3 certificates. So let's generate the first one. And let's name this as the SSL root CA. And common name is going to be the same. And we're going to select certificate authority and we're going to generate. Okay. And now we're going to generate another certificate. And I'm just going to change this to be SSL. So that's going to be trust. SSL. Actually, let's make trust forward SSL. Let's do this certificate. So trust forward certificate. Okay, that's trust SSL certificate. Trust SSL certificate. Yes. And this is going to be signed by the root CA, the SSL root CA. And we're going to select also certificate authority. We're going to generate. Okay, and now we're going to generate the source certificate. That's going to be on trust SSL certificate. Going to use the same name here. Now this is going to be a certificate authority and won't be signed by any root CA. Okay, we're going to generate this. Okay, so we have 3 certificates. Now we go to SSL root CA and we want to enable this box, trusted root CA. We're going to save this. The second one, the sub CA, we're going to enable forward trust certificate. This means that this is the certificate that the firewall is going to present to the clients when they try to reach a server that the firewall trusts that certificate. Okay, so that's going to be the forward trust certificate. And the last one is going to be, well, the untrust certificate, which means that for those servers that the firewall doesn't trust the certificate, is going to present this certificate to the client. Okay, so we're going to save this and commit those changes. Okay, changes were committed successfully. So next we go to objects, and here we should go to decryption profile. And we're going to add a new decryption profile. Okay, so we're going to name this as SSL Forward Proxy profile. Okay, and what do we want to do when we are using SSL Forward Proxy? So we want to block sessions with the expired certificate. So we're just going to select all of these. And also unsupported versions. Okay, that's all. And we're going to save this. Next, we're going to create a decryption rule, which means that what do we want the firewall to do based on the certificate. So I'll go to policies, decryption, and here we're going to add a new decryption policy. So just going to name this as SSL decryption rule, and the source is going to be my inside zone and the destination is going to be the outside zone. So service options. So here the action, we want to select decrypt, and the type is going to be SSL Forward Proxy, and the decryption profile is going to be the SSL Forward Proxy profile. Okay, and we're going to save these and commit those changes. Okay, so now let's go to Linux 6 and enable HTTP and HTTPS. So to do that, let's see, systemctl status Apache 2. So it's loaded, but it's inactive. Okay, so before starting making any change, let me bring my script here. So these are the steps that we have to take to enable these. So first we have to enable A2 AIM-mod SSL. Now let's see if everything's okay. Conceal enabled. Yeah, looks like we're okay. So we don't have to restart because I didn't enable the service yet. Okay, so next let's go to this directory and edit this file Apache 2. So I'm going to use vim etc apache 2 conf, and right here at the end, so at bottom, this is I have to add, so directory, and that's going to be var HTML, and allow override all. I'm going to close this. Okay, that's it. Yep. And the next we're going to create a directory. So let's go to etc Apache. Okay, so I'm going to create a directory, certs, get inside this directory, and then here we're going to generate the certificate. So we're going to use OpenSSL request new key RSA 4096 X509 256 nodes out Linux. So that's going to be Linux 4, no, it's going to be 6, and the key out is going to be Linux 6.key. Okay, so country name, that's going to be PT, province Lisbon, city Lisbon, organization name, that's going to be my company name, binary avenue, organization unit IT, fully qualified domain name, so that's going to be Linux 6. Am I using 6? Yeah. And address name, so pki at binaryavenue.com. Okay, so we should have 2 files here. Okay, lastly, so we should edit the files at this directory. So vim, and here I'm just going to change this to 443, and I'm going to include, so what do I have to include here? Okay, and that's going to be SSL engine on SSL certificate file. So this is where I have Apache 2 certs Linux 6.crt and SSL certificate key file PC Apache 2 certs Linux 6 key. Okay, and yep, you can save this. Okay, and now we're going to start systemctl start Apache 2. Okay, looks like everything is okay. Let's double check. Yeah, it's running. Okay, HTTPS. So we can validate that by going to our local host IP address. Okay, so here I can type just 127.0.0.1 So that's working, meaning HTTP is working. Now what about HTTPS? Okay, it's also working. Accept, and yep, it's working. We take a look at the certificate. Let's take a look. More information. View certificate. We should see Linux 6, binary avenue, IT, Linux 6. Okay, so that's great. So we have the server running HTTPS. Now let's try to reach these two servers from our Linux PC. I'm going to close this and let's see what we're going to see any difference now. So first, let's go to HTTPS 116.8.4.14. Okay, so we got a warning there. Accept and risk continues. So now we have a different message, which means now the firewall is intercepting the traffic. And based on the rules we have, like it's denying or allowing. In this case, it's blocking this session because it's an untrusted issuer, meaning the firewall doesn't trust the certificate that the server is presenting. Okay, let's try from the other one and see if we're going to get the same message. So for 6, so we got a warning there. Accept risk and continue. So the same thing. So Linux 6, untrusted issuer. And if you take a look at the certificate here, more information, we should see that we have the information about the server certificate, Linux 6, binary avenue, IT. And look at this. We have this information issued by Untrust SSL certificate. And if you recall, this is the certificate we generated on the firewall for untrusted issuers. Okay, so if we go to our objects, decryption profile, no, should be here. Yeah, the Untrust SSL certificate is being presented to the client. So Untrust SSL certificate, and we can also validate that by going to monitor. And here we can see that we have, based on our SSL decryption rule, so it is being denied because it's untrusted. And if we go to logs, traffic, we should see some information related to this as well. So we can see traffic is being denied, and the reason, let's see, decrypt cert validation. Okay, the firewall is able to intercept the traffic and is able to inspect the traffic, and based on the conditions we set on the firewall is blocking because doesn't trust the certificate on those servers. So how can we fix this, or what is the workaround in this type of scenarios? So there are a couple of things that we can do, but the simple one would be just to make the firewall trust the certificate on these servers. And we're going to do this just for one of the servers. That's going to be the Linux 14. So on the Linux 14, let's log in. We're going to place the certificates where they are. So we have these two files, the CRT and the key file. We're going to place in this directory. So var //html, so that we can download those files and import into the firewall. Now, this can be this is a workaround that I found out just because it can be very hard to export things that are inside these VMs and trying to get outside of them. So this is one way that I found, but you can apply any other option. Now we have to download these files, and to do that, I'm going to use Linux 5. I'm going to close all of these, and I'm going to use this command. So get HTTP 116.8.4.14, and I want to download this file, Linux 14 CRT. Now I'll be able to do this because I know that this file is in this directory, so you have to copy this file to this directory. Okay, so I have this file, Linux 14 CRT. So now I have to import this file to the firewall. And to do that, I have to open the firewall from this Linux PC. So let's go to my local IP address and advance, accept the brisk and continuous. Just reduce the size here. Okay. Admin. Okay, while it's loading, let me show you something as well. So in order to access the firewall using the data plane, using the data interface, in this case, I'm trying to get to this firewall, manage the firewall using the interface 1/1. I did create the interface management profile. So let's go to device. I believe, is it device or is it, let's go, probably it's network. So yeah, so that's the interface management profile, and this management profile I enabled HTTPS. Okay, so that's how I'm able to access this firewall, to manage the firewall using the data interface. Now back to my Linux 5, I'm going to disable this. So now let's go to device, certificate management, certificates. Okay, and then we're going to import, to give it a name. So it's going to be Linux 14 certificate, and the certificate file, just browse to downloads. I'm going to select this file, open, and we're going to import to the firewall. Okay, certificate is imported. So now let's enable trusted root CA. Okay, and now we're going to commit the change. Okay, change committed successfully. So now I'm going to close these. I'm going to open again. Okay, let's try to go to first 116.8.4.6, and we should see the same message, right? The firewall is going to block this session because this is an untrusted issue. Now let's do the same for 116.8.4.14. Okay, same warning, advance, accept the risk and continue. But now we are able to see the page. And why is that? So if we go to connection, secure, more information, view certificate, we should see that we have the information about the server, but now the firewall is presenting us the Trust SSL certificate, and that's the certificate we created to be used when the firewall trusts the server certificate. And we can also validate this if we go to monitor, take a look at traffic. Okay, we should see SSL and non-TCP, so it doesn't have much information to identify which type of application. But if we go as well to decryption, okay, so here we're not going to see the successor handshake because we go back to policies, decryption. We're going to see that I didn't select this option to log successful SSL handshake. But anyway, this is how you deploy SSL Forward Proxy. So if you took value from this video, don't forget to subscribe, hit the like button, and I'll see you on the next one.